This is Rico with Maker Code, and in today's episode, we're doing a progress report on where I'm at with this project. I've got a LiDAR, I've got a robot, I've got a rover. It's moving, it's mapping, but does it work? Let's find out. Hi, this is Rico with Maker Code, and today I'm doing an update on everything that I've built. Still working on things, but at least I thought I could give a quick update on where things are, how things are going. Am I even going anywhere in the right direction, or am I just spinning my circles? Actually, things have been really good. Moving along, I've come up now with a kind of a test fixture, and I thought I'd give a quick update to what it all is and how it's all doing. So let's take this off. So I have just an angle bracket right now holding this together. And what this all is kind of a test bed that contains all of my electronics. So let me bring this up and off. Let me disconnect the power right now. We'll go over what's below this afterwards. So let me put this away for now. And let's look at this guy. So what do we got here? Okay, so the things I have been researching tell me that I would like Fast-LIO 2 with RTABMAP. Okay, what does that all mean? Basically, I wanted to do what my robot vacuum could do, which was map the environment and then be able to reuse that map to navigate. It's kind of the baseline I wanted. So what I needed for that was LiDAR, camera, and a CPU, some sort of processing power. And so what I decided to do was, first we have down here just a Jetson Orin Nano Super in a case. And I specifically chose this case for, there's a power button. And then it also came with Wi-Fi antennas so that they could be sticking outside of the casing. It had two 2.5 millimeter screw on the bottom, so I could screw this into a base plate. And so I quickly created just a 3D printed base plate. And so from there I have CUDA core, and I have just some sort of compute power. I could have chosen a Raspberry Pi also, but at least with the CUDA I could use some of the other depth cameras with this same platform. And so that's kind of why I went with the Jetson Orin over a Raspberry Pi. I probably could have done it just as well with the Raspberry Pi, but this just gave me a little bit more headroom. Okay, now we'll circle to the back here. And I wanted this, what I was finding is power. I didn't want to be tethered in any way. So I just quickly have a battery pack adapter. I can take just a normal DeWalt battery and be able to plug it in. And now I have 20 volts, but some of these devices only work on 12 volts. So I have a buck converter here that converts the 20 volts to 12 volts. So the 12 volts come out into this distribution. And so these are just using XT60 connectors. And so my thought process here was power pole connectors. We'll use anything above 12 volts. Then anything at the 12 volt range, I'm going to stick with the XT60s. And so some batteries may come with the larger, some LiPo batteries may come with the larger XT, was it 90 or whatever. And that's fine. I could just adapt this to power pole so that the power pole out of the battery into whatever buck converter I have. Okay, so a lot of this I've been doing research back and forth with Claude. And the reason being is I don't want to waste my money buying something and then realizing I should have bought something else. And Claude is very good at saying that. So some of the things are this buck converter. This is a Pololu one. And before I was just using these run-of-the-mill, where are one? Where is one? Well, there's one underneath here that I mounted. So I was just running these run-of-the-mill ones that you have for like a big wheel or something. And basically what they're saying is that those will work. They will convert my 24 volts to 12 volts, but it's a very noisy signal and you will start causing some issues with your power. So I will say that Claude Code is a very good salesperson. So they are constantly pushing me to buy the right product so I don't waste my time and money. And I'm always asking it, fine, why? Give me enough justification to spend the extra money. And a lot of times it's not that it's that much more expensive, but the shipping cost gets you all the time. So with shipping, why would I buy this buck converter over just buying the cheap ones I can get on Amazon endlessly? And so a lot of details into basically the signal causing some noise in the mechanics of the electronics. And so this will at least be a clean signal of power, which then the processor and all the devices will not have any issues with it. Fine, let's just go with it. So again, then I'm just outputting to the 12 volts coming out of this buck converter into this distribution board. And then, this is powering the Jetson Orin Nano, it's powering the LiDAR, and it's powering a USB hub. So one of the things that I had to worry about, so this is a Waveshare powered 3.2 USB hub. So one of the things I had to worry about was just having enough USB ports. One thing that's very clear that you'll find out is that the depth camera is USB usually, and that USB bandwidth is maxed out. It's totally maxed out on one USB port, rail, whatever we want to call it. So you can't have multiple USBs kind of plugged into the same rail. So the Jetson Orin, I believe, has 3. It has 2 USB-A ports and then a USB-C port. And so, again, Claude is suggesting have one dedicated port for a depth camera, have a second dedicated port possibly for a second depth camera, and then have the third USB port be a USB hub, and then use the LiDAR, the IMU on that USB hub. Basically, they're saying that the bandwidth is not going to be that high on the Ethernet port, doing the UDP data from the LiDAR, and the IMU is also not going to tax the USB port. So connecting those both to a USB hub, highly suggested by Claude, fine with me. So I have this USB powered hub, again, powered so that I don't have to worry about, again, issues with the devices not having enough power when they're running. So it has a just a normal terminal plug, and that is getting 12 volts from the rail or from the distribution board. And then it's just USB out to the Jetson. So not that big of a deal. Next, we're at the top here, and we have a LiDAR. And so I designed this plate, as in me and Claude, have designed this plate to be interchangeable. So this whole frame I have built to be the same dimensions as this mount that I 3D printed off Maker World that fits right on top of the Unitree Go2. So this, I then, so you screw them in here, and this is where the power port and Ethernet port is. And then in the front, there's 2 more screw holes. And the whole lid is attached by that, but I just replaced the screw lengths so that this could just screw right on top. So this sits right on top. And then I have these T-nuts so that I can slide these in, and the dimensions are basically intended to sit right on that. So that's how I chose this overall dimension. I could have went bigger, I could have went smaller. Some of the things that I was also worried about was just thermals. So in here, there's a fan output, and I didn't want the USB hub right on top of it to block it and just kind of recirculate the air. So I wanted enough air in there. In here, I have it blank because actually this will be cut out in this section here, because that's where the port for the Unitree Go needs to have cables come out. So I had to make sure that that was a blank area. Right now it's not blank, and that was more just trying to figure out where these screw holes were going to go for this bottom plate, because this this Jetson case is wide, and I also had to worry about the cabling sticking out. This was kind of the orientation I chose of the Jetson with this case, and so with that, the width, I can't just screw the screws into this rail, this 2040 rail. So I'm gonna have to figure out, I might just do a cutout in the back here. So since it's 3D printed, quickly I can change it. But one of the important things that when I was designing all this was the back of my mind, I was thinking of this URDF configuration. So basically that is doing all the measurements of where all these sensors are located on the Unitree Go or any other robot. I needed to know the exact dimensions. So one of the main things I did is I told Claude I needed a LiDAR mounted on a plate of this dimension, and I needed the IMU mounted on that same plate. You designed me a DXF file, which is basically like a you could say it's a text file, but basically it's just a description of this plate in 2D space. I then put that DXF file into Fusion 360 and just extruded it 7 meters. 7 meters was chosen only because most of the heat inserts were 6 millimeters. They could have been 3 millimeters. It was all over the place, but for the most part, the largest ones were around 6 millimeters. So I chose 7 just to make sure I'd have enough meat for the screws. I'd have enough meat that this doesn't flex too much. And then I just have some wiggle room that I can play with the thickness if I really had to. Okay, so the LiDAR sits on top and the IMU sits on top, and the orientation and distance in between was dictated by Claude. And the reason why I did that was then when it came time for me to have to generate a URDF file, I could tell it, take the measurements directly from the mounting plate that you generated. So it knew where to look, how to determine all these locations, and I didn't have to worry about it. The only measurements I did have to give after that were this overall height, because it already knew the length and the width, and it knew the thickness. It knew the location here and knew the location here. And I needed to give it the location of the camera. So the distance between the front face of the camera and this face of the mounting plate. And then this is a 3D printed mount that I found again on MakerWorld, and there's a pitch to it. So I had to go and figure out a pitch. I had like a little tilt sensor that I thought would be good, but this is rounded, so it was really kind of actually difficult to measure out what this is. Claude wrote an actual piece of Python code that took the measurement from the depth camera to dictate what the angle was and came up with that this is 10 degrees. So my tilt sensor measured 20, ran it through. It was saying it didn't look very good, wrote that program and came up with 10, reran all the validation. And yes, it said 10 is the right number. So 10-degree pitch, pretty awesome that Claude could do that code because that would have been off. But again, all I had to do was give it this height. It already knew the length and the width. Another suggestion Claude had was vibration. So these are little rubber mounts. It'll go down, but the screw is bottomed out, so it can't go up anymore. And they were just worried, Claude was again worried about the vibration that this was causing. If there was going to be vibration, it wanted the IMU to see the same vibration as the LiDAR. Now, The LiDAR, this one specifically, the Mid-360, has a IMU built into the LiDAR. So I don't even need the IMU for this setup because it's already in here. I can use it as a backup, and when Claude was setting up my launch files, it has it even built in where I can turn it on and off just to do some testing to see if that's necessary. But again, because Claude is making my mounting plates, I told it, using the same mounting plate, make me 2 more. One for the PANDAR 40 and one for the VLP 16. Same mounting plate, same IMU location, and again, they can the Claude can generate the URDF because it already knows everything it needs to know about the VLP 16. It already knows everything it needs to know about this mounting plate, and it already knows the distances. So camera is not changing. IMU is not changing. The only thing is the LiDAR and this mounting plate, and Claude already knows that all in the project. So made my life a lot easier, and it'll make it so that I can swap these out. So test out Fast-LIO with this, then test out Fast-LIO with this is repetitive. So the repetitive just lines to see what the difference is. 16 lines versus 40 lines. Am I going to see a huge difference? Can it just work? Is range really an issue? Is 360 really an issue? All those things so that RTABMAP can then also do loop closures and stuff like that. So I have a lot of different options now with just these mounting plates. And because I'm using this 2040 extrusion, this camera mount is not restricted to just this camera. I can mount the other cameras on here. And so, like I have the other one suggested was the Oak D Pro would be a good one because it also has object detection built in. So it doesn't have to use any of the processing power on the Jetson. But basically, this one I believe either has an M5 or another quarter 20. But I could just make a 3D printed mount and mount that on there also. And the URDF is a pretty simple modification that I can describe to Claude to make that modification. So with all this, there's an on and off switch on this. I specifically chose this DeWalt mount because it has 2 holes in it so that I can mount it on the rail also very easily. Some of them you have to be careful. They don't have holes, or the orientation of the holes may vary. So this one I would have to mount sideways versus this one, the bolt holes were the opposite direction. So also when you're ordering those, think about the orientation that you want to put your battery pack, because this one has only 1, this one had 2, the other one had 2, and some have none. And that does make a difference in how you plan to mount this. Okay, so now this thing is self-sufficient. I can walk this around and do some testing. But right away, and I mean immediately, I found when trying to do this, basically I have to hold it above my head to do the mapping if I even want to start testing this. Because me being in the picture holding this, the Fast-LIO is not happy, and it always fails. And so what you see as a failure is, and I'll show it, but basically you see on the map, it's sitting there. And so for the first 30 seconds, do not move, do not do anything. Let that thing start accumulating data to get a baseline. And me standing there holding it, I am moving around, trying to hold it still. And at the same time, it's seeing me, and I'm moving around just a little bit. My arms are moving around, the fixture's moving around, and immediately just the LiDAR map just starts to drift off the map. And so kind of here, you would just see it just go off the map. Okay, so I needed a way to fix that. So the easiest thing to do is just walk away, turn it on, let it run, but I can't come over to it to like rotate it, because me walking in and then rotating it, all of a sudden it was happy just sitting there stationary, and then just drifted away once I started to move it. So I needed something. And obviously I had this mount to go on to the Go2. But I'm not committed yet to mounting this entire fixture. It's not a small fixture. It's not light. It's about, without the battery, because I won't need the battery when it's on the Unitree Go2, it's around 8 pounds with all this. So I didn't want to make that my first test, is put it on the Go2 as the first test. So quickly, again, working with Claude, we came up with an idea of making just a quick test platform. So I found on eBay these motors, $5 each one. These are low speed but high torque. So they're 99 RPM, but that is about the speed that my robot vacuum does anyway. And then I did the mecanum-wheel so that I could move sideways, forwards, and rotate. So next, motor controllers. I have endless motor controllers that I've used throughout my life. I have the Saber-Tooths. I have just the cheap ones that you can buy, and individual ones that have 1,000,000 wires that come off of it. But working with Claude again, being the salesperson they are, they suggested this Yahboom motor controller. Point being there is this motor has encoders in it. This board is specifically intended for these type of motors, these Pololu motors. These are Pololu motors that have the encoder wire built into all of it. So the added benefit of this motor controller is that you can run ROS2 commands into it. So it will be able to understand the teleop communication that ROS has. So I could then connect it to the Jetson through USB and just have it serially receiving the teleop commands. It knows how to decode them, and then it can control it through ROS. But I don't plan on doing that right now. I just needed to just get this up and running just so that I could move this whole platform around. So I just have it hooked up to a controller. So just an RC controller, same one I use for my R2D2 and other projects. It has S-Bus built into it. So S-Bus is connected to it. I then have to just, this extrusion lengths were not chosen specifically. They were actually just these bars. I had some extra ones just in case I was gonna put some in between. So these lengths are just these lengths. So the width and stuff like that, this was not chosen to be the actual dimensions I would have chosen for this platform, but just to be quick, I already have them cut, and so that's what I use. So right now it doesn't quite fit on here well. It sits on just the corner here, this length, and the back bar. So it doesn't sit on this, but at the same time, this board has a specific power connector that sits really high, so I was gonna have to make this higher anyway. I didn't want to deal with all that right now. This also can run on 12 volts. So I just have this now plugged into this same power distribution to give me 12 volts. I quickly use an angle bracket just to mount this on. So this is just attached by an angle bracket. But again, these are really low speeds. So I'm not really worried that this is going to do a wheelie or I'll flip over. It's just so that I don't stand on top of it and it can rotate. So now we will power this guy on and run the commands. I have been letting, again, Claude design all my launch files so that I can have all these different scenarios. So I have some where only one sensor is running. I have some where all the sensors are running. I have some that are set up for Fast-LIO. I have some that are set up for mapping. But for right now, the ones that I'm testing are for Fast-LIO 2 to run. And so we turn on the power on the on the back of the power block. That then powers this. It also will then start to turn on all these devices. The Jetson has its own power button. So I press the button to power it on. And now you hear the sound of the LiDAR spinning up. So there is a spinning portion in there. You will be amazed at how much louder this little guy is compared to something like the VLP or the PANDAR. This one actually is a lot louder than you would expect it to be. We will also turn on the Yahboom board. So it has its own on and off switch so that if I am using it to drive around, I can monitor that. There's a little screen output, so I have a little screen attached to it. The screen doesn't really give you too much information. And then if I turn this guy on, it's going to complain about all the settings. Yes. And I'm going to lift this just in case for this test right here at least. Move that out of the way. Okay. When you are installing or buying mecanum wheels, mecanum, I don't know how to say it, there is a left and a right wheel. So you got to make sure you get the orientation right of the right ones and the right left ones in the right spot so that the rotation is done right. This board has it built in so that it can handle all the different type of wheel driving you would do, whether it's steering wheels, kind of tank driven wheels where just one side is one direction, or in this case, the mecanum style wheel where they're omnidirectional. So now that I have that all set up, let's get this moving. No, okay, there we go. So I can just go forward, and then I can also crab to different ways. So next thing I have to do is I utilize Foxglove to stream all the information out when I am running these commands. I use an application called RustDesk. It's like a remote desktop, but it's a little more available, you can say, to all the different devices. So it works on Windows, it works on Linux, it works on Apple. And then as far as one of the problems I was having with like Real VNC or RDP is because there's no monitor on this, I couldn't just wake it up. So actually I have a dummy DisplayPort dongle in there so that the Jetson always assumes there is a monitor plugged in. So it's always alive. And then all these apps can work where I don't have to worry about moving a mouse to wake up the screen so that the thing will display, or plug in a screen that disconnect the screen. And then I have something working on these remote viewing softwares like RDP or using Real VNC, or like I'm doing now using RustDesk. I've been liking RustDesk lately, so I've been sticking to that one. It seems to just work right out of the box. And I am not going to be using the IMU. And I'm also going to do the LiDAR transform, and I'm not going to be using the camera. So it's basically just the LiDAR right now, just to make sure Fast-LIO is working, just so you can see it. A lot of this, since I'm doing it with Claude Code, I have a project file, project folder, and I work between my laptop and the Jetson board, and I basically will ask questions on my laptop and then commit the code. And then on the Jetson, I will pull that latest code, and then vice versa. On the Jetson, we're troubleshooting, and then I will commit that code and then pull it back on my laptop. That way I'm moving back and forth between the two and seeing all the information I need. Okay, so now we have that all running, and we're going to run this Fast-LIO setup now. So I have the sensor board. So the sensor's working. So basically it's taking LiDAR data. You can start to see LiDAR data here as far as this is the IMU. If I were to change the topic and the display, you would see the information. But for now, this is not what we're doing. We're not looking at raw LiDAR data. We're looking at Fast-LIO data. So let me start the Fast-LIO script now. So we'll launch Arvis. but you can also see it on Foxglove right here on the screen. And so now, let's see if you can see that. Let's expand this out. We have the LiDAR map. But again, I am in this area throwing it off completely. So let's turn down the decay. And like I said, the first 30 seconds are most critical for this guy. And because I'm in that realm, I am throwing off the Fast-LIO stuff. The number one suggestion that Claude had is just put it in your living room, because then it'll have the couch, it'll have a smaller ceiling, it'll have walls, it'll have tables, it'll have couches, it'll have all these things to just reference off of, where in my garage there's not a lot going on in here, so it's not too happy. Okay, so I'm trying to see if this will stabilize. Let's pull up Foxglove so I can see it. And yeah, it's still drifting around even though it's sitting stationary, as you can see. So that's where I'm at. We're almost there. I have a moving platform so I can run some tests. I have LiDAR being output. I have Fast-LIO being started. Work out these new issues that I have. Again, it's just a back and forth with me and Claude. I will say, though, that this is using Claude has dramatically increased our production. Before, I have used ROS before. Just getting this ROS environment set up would have taken me more than 2 weeks. I did it now in about 30 minutes. So, dramatic change in production just using Claude alone. I do use Claude Opus. I do have the $100 plan, the $20 plan. No, it's not going to get you there. You definitely need the $100 plan to do this. I will say, though, the $100 plan pays for itself in a month very easily with all the things you can do, work-related, hobby-related, just general questions, research. I have it connected to my Obsidian notebook. So as I see a YouTube video or a GitHub repository, automatically I have skills built in now that just say, hey, here's the URL. Dump that all into my Obsidian notebook, add it to the wiki that I have in Obsidian that Andrew Karpathy had shown that is a good way of reducing token usage by searching your wiki first. That's just your Obsidian notes before it goes and tries to dump a bunch of research into doing other places. So yes, this has definitely helped. It also then with the memory and stuff like that, it figures out, oh yeah, I assume you're talking about you were doing this for this robot platform. Is this correct? Yes. Let's keep moving on with that subject. So definitely would suggest using something like Claude for this. So the next thing is get Fast-LIO to work, get our RTABMAP to work next. I keep almost getting there. I'm so close to getting it there. And what that will do is, when I was losing the map, it's called loop closures, what they keep calling it. So it will basically kind of sanitize and say, hey, I have seen this before, so this is actually where I'm located, instead of drifting away. Let's see if that really works or not. Also try the different LiDARs. I also want to do an outdoor platform. So I bought some broken hoverboards for $9 on OfferUp. So I plan to make similar to this platform, but using nice big beefy wheels. It's also brushless motors, so that's a whole new thing that you have to deal with FOC and stuff. So it's something I've been really interested in, of migrating away from brush motors to brushless, because you can do a lot more with it. But it's a whole new learning curve and a whole new set of hardware that I don't have, that I have to buy and set up. But that is next on the agenda. Might be tracked, might not be tracked. I haven't decided. Leave me a comment if you think tracked would be better. I'm still on the fence, but there will be 4 brushless motors, 4 brushless wheels. I have 2 hoverboards. The guy was selling them both. Basically, the batteries were dead, blown up. So, yeah, hope this helps everybody. Like and subscribe. I will just keep on coming out with more If you like these kind of behind the scenes, let me know, because at the same time there will be summaries and stuff like that of what's going on from the bigger picture of things. But this is kind of in the weeds of what I'm doing right now as we speak, going along. If you want to see any other LiDARs, let me know. I do have single scan LiDARs. The Nito one that was kind of in the old robot vacuums. I have just a single point one. I also have the Unitree L1. So it's this guy right here. So I also plan to do that one. The hard part with that one is this has something spinning and the other ones have something spinning. That one physically spins, so you can't just touch it, kind of thing. So I might build a cage. I was already looking to how I'm going to build a cage around this when I do put it on the Go2. But also things like that I got to take into account. But I mean, I am testing a lot, as much as I can, just to get an understanding of LiDARs and how they work. And then when that's all done, jump into the depth cameras. So RTABMAP is more going to be utilizing the depth cameras. So try a bunch of different depth cameras and see what works best with it. Again, based on working with Claude, it's definitely suggesting the D435. Why? Because it's good for indoor and outdoor lighting. So I don't have to worry about sunlight having any effect on it. I do know from past experience that any type of AI stuff or training stuff, that the moment sunlight was introduced, sun is here for some of the training, some are here, sun is there, you get a glare, you don't get a glare, that's dark, so there's no sun. That's so many variables that yeah, it was very difficult to handle the sun. So then you kind of keep it in this hermetically sealed environment, and then you feel like it only works in this little window. So yeah, D435 was suggested for indoor outdoor, so I don't have to worry about those kind of things. But yeah,